What's going on, guys? Welcome to your next machine learning interview preparation tutorial. And in this tutorial, we'll be focusing on practicing a resume. For example, my resume. And this will be a great opportunity for you to show your domain expertise to the interviewer, which can be also a way for you to show how passionate you are toward the particular field you're pursuing. So let's walk through the structure of the resume. So I have an education section. So you can see I have my school. I also have an extra academic uh, activity that I'm pursuing too. And I have professional experience, which shows my work history. And then I have technical projects from academics to industry. All right, let's dive in. So thank you for this opportunity. I really appreciate it. It's a little bit about myself and why I got into computer engineering and also got interested in doing machine learning as a career. So when I was little, I used to watch my grandpa work on cars. He was pretty good at fixing the problems in cars. But I also noticed as he was working on a car, a portion of his index finger was cut off. And it wasn't until later where I learned he was fixing someone's washing machine, and that's when the incident occurred. And uh, what I learned from research was that engineers and scientists are the ones who fix those problems. And later I got introduced to computers and video games, and I made a decision to pursue computer engineering for school. At SJSU, I specialize in real-time embedded systems, and I also got introduced to machine learning with big data. And currently I'm working through Udacity's self-driving car engineer nano degree, where I'm learning how to build the software stack for a self-driving car using computer vision, so OpenCV, let's say, and deep learning, so TensorFlow, Keras, all the way down to the robotics with ROS. Now, my professional experience. Most of my time in industry, I have been working as a technical marketing engineer. I started out at Hortonworks as an intern and later transitioned to being a contractor when Cloudera and Hortonworks merged together. My responsibilities throughout these roles include collaborating with software engineering teams to prototype, refine, test, and debug sample applications from telemetry, deep learning, computer vision, sensor fusion, and robotics to installing Hadoop clusters and creating data pipelines using various software and hardware technologies. I've also been responsible for creating AI ML developer content as well as big data developer related content in the form of the technical blogs, tutorials, presentations, and videos targeted to customers, internal teams, and practitioners to teach them how to use AI as well as big data technologies for their various use cases. I've had the opportunity to talk about Cloudera's self-driving car sample application at the DataWorks Summit in Washington, D.C., where I talked about the car software stack as well as integrating Cloudera data products into the application. And I've had the opportunity to also talk about I've had the opportunity to talk about HTTP3 cluster deployment on 8 boards, so commodity hardware, where I discussed the hardware setup, CentOS network installation, and HTTP GUI installation. And that was with a sales engineering audience. Actually, throughout my time as a technical marketing engineer, a lot of it also was around quality assurance engineering, and that involved reviewing, analyzing, modifying the AI and big data tutorials through testing and debugging their problems using small-scale sandbox systems. One of the projects that I'm most proud of during my time at Hortonworks and Cloudera is the small-scale self-driving car sample application. In this project, I developed a race car Jetson AI application that clones a user's driving behavior based on perception and decision-making data, then controls a car to drive safely around the track. I needed to pre-process the data first, so I created a data pipeline to collect the driving behavior data, clean images with image normalization and cropping, augment the data through image mirroring and steering inversion, and load it into Hadoop. I then later needed to also validate the quality of the data being collected, so I created a React and Express.js web telemetry application that visualized the car's camera, steering, and speed data in a dashboard. Once I pre-processed the data and validated the quality of data uh, so that it was ready to be used to train the model, I then developed a Keras convolutional neural network model based on NVIDIA's self-driving car neural network architecture to predict the car frame steering angle. Then I trained the model with an Atom optimizer for 7 epochs. I validated the model with the mean squared error loss and tested the model's driving skill by deploying it onto the Jetson and had the car drive itself around the track for at least 1 lap. This project, one of the highlights was being able to work with my coworker, train that coworker on the process of integrating AWS EC2 instances with Cloudera data products with the self-driving car, hardware and software, which with slight modification would allow for deploying fleets of autonomous vehicles. This project benefited the company because it would later become a Cloudera internal certification as well as a customer-facing demo. And I had the opportunity to work with the sales engineers to make that happen. Next, I have my Udacity nanodegree projects, just a few that I'd like to talk about: the traffic sign classifier object recognition project using TensorFlow, and the advanced lane finding object detection project using OpenCV. So for the traffic sign classifier project, I developed a traffic sign recognition application that learns to classify 43 different traffic signs from a German traffic sign data set, then displays the top 5 softmax probabilities for 5 test images downloaded from the internet. So first, I pre-processed the data by creating a Python pipeline to collect traffic sign data, validate the distribution of that data through bar graph visualization, augment the data with image rotations, and clean it with normalization. Now that I had the data cleaned and ready for the model training, I went and implemented a TensorFlow CNN model based on Jan LeCun's Linnet architecture to predict a car frame's traffic sign type. Then I trained the model by selecting Atom as the optimizer, 64 batches of data to be used to train the model, going over the entire training set with those chunks for each epoch, over a total of 10 epochs being used for training. Then I validated the model's prediction accuracy on the validation set and tested the model on 5 new German traffic signs that were downloaded from the web. The model's overall performance was that the model achieved 96.4% prediction accuracy when it came to the testing set, and it achieved 60% prediction accuracy when it came to the new web images. So that made sense because with the German traffic sign data set, the data was a lot more clean, whereas the images from the web, there were a lot more noise and distortions in the images. So 60% isn't too bad, but there could definitely be improvement for that project. Then we come to the advanced lane finding, object detection application, and in this one, I created an application that visually tracks the lane boundaries, lane curvature, vehicle position with respect to the center of the lane. And this was done from an image, from a video captured by a camera mounted to most likely the center of a car. And I used various OpenCV techniques from camera calibration, gradient and color thresholding, perspective transform to get the bird's eye view of the image, splitting the histogram to be able to find where the lane lines start, sliding window method to be able to draw out polynomials along the lane markings, and then search from prior method to be able to save time when it comes to drawing out the polynomials on new images. If the new image is similar enough to the previous image, then we do a search from prior. If it is very different, then we'll have to do sliding window again to recalculate the new polynomial for those particular lane lines. Overall, this was a great project, and I learned a lot about OpenCV and Python. And now we're on to the MP3 player project from my real-time embedded systems class. So this project was really good. I had an opportunity to lead a team to design a music player embedded software application for consumers to upload their favorite songs onto an SD card, select their favorite song to play from a playlist, and adjust the volume to their liking. My other role in this project involved developing a C++ peripheral device library for the SPI, serial peripheral interface LCD display, and the MP3 decoder device. When I finished my tasks and my team also was done with their tasks, we came together to collaborate to integrate the FreeRTOS MP3 decoder task, LCD display task, SD card task, and GPIO playback controls task to produce a fully functional MP3 player. The final part of this project was to demo this MP3 player to the class by playing a song, adjusting the volume, scrolling through the song list visible on the LCD display, and using the playback controls. The result from our project was that we got an A grade and we also got positive feedback. So I hope you guys got something out of this tutorial, and it's always good to practice your resume. I try to practice mine on a daily basis, just to stay ready for those machine learning interviews. So looking forward to seeing you guys in the next tutorial, and take care.